Hey everyone, this is lesson 39 and it's multiplying decimal numbers. The slides that you see in front of you right here are actually lessons 39 and 40 combined, and we're not going to be talking about lesson 40 today. It's using zero as a placeholder. It's something that we've done before, and we're just going to move past it because I feel pretty confident that you're familiar with doing that. So we're going to focus on multiplying decimal numbers today. What do you do with your decimal? What gets lined up where? And let's take a look at our learning targets. Oops. We're going to multiply a decimal number by a decimal number, and also we're going to multiply a decimal number by a whole number. So what to do in both of those cases. When you're multiplying decimals, we've just finished up talking about adding and subtracting decimals, in which you line up your decimal. And when you multiply decimals, you don't do that at all. You do the complete opposite. We line everything up on the right side. So lining everything up on the right side like this, you can see in this example right here, we do not have our decimals lined up at all. This is just a really good example of, instead of actually going through and doing every single number and multiplying the zeros, this example right here is highlighting, that's why these are in blue. What they've done is just take the 75 times 5, which gives us the 375, and then applied our decimal. And now this is why. When you do decimal work, when you're multiplying, you solve like normal, like they've just solved this problem, and then you go back to your original problem and find out how many decimal places you need to bump back to put your decimal. And when I say bump back, it's because we start here on the right side and work our way back to add a decimal. So I'm just going to start by counting here. We have one decimal place. That's why we have one blue number. And then up here on top, we have two decimal places. So altogether in our original problem right up here, we have 3 total decimal places, so that when we go down to our answer, we start here at the back and we count 1, 2, 3, and place our decimal right there. So we end up with 375 thousandths. Based on that information, give this one a try. We have 25 hundredths times 7 tenths. Remember not to line up your decimals. You're going to align everything on the right side. Multiply this like normal. Place your decimal where you think it needs to go, and then unpause your video when you're ready to check your work. All right, so I've gone ahead and set up my problem. Because of the commutative property of multiplication, my numbers can commute or travel around in any order that I'd like them to. I personally prefer my bigger, or this isn't actually a bigger number, my bigger looking or my longer number to go on top, and my shorter number on bottom. Visually, that just works better in my brain. Whatever works for you is the right way. So I have 25 hundredths times 7 tenths. I'm going to multiply this and then place my decimal where it needs to go. I have 7 times 5 is 35. 7 times 2 is 14. 15, 16, 17. Come on. Okay. And then I can go ahead, I can put a 0 here if I want to. 7 times 0 is 0. I could go through and multiply all of these out, but I know that those are all going to provide zeros. I'm going to save myself this step here and start to decide, where does my decimal need to go? Well, let's go back to our original problem and determine how many decimal places I need to bump back and place my decimal. So I'm going to start right here. I have 1 decimal place. I'm actually just going to draw out these bumps as I'm counting them for the visual. I have 1 decimal place here and 1, 2 up here. So altogether, I have 3 decimal places that I need to bump back in my answer, in my product. So I go down here, start at the back here on the right, and I count back 3 spaces. 1, 2, 3. And my decimal goes right here. I've ended up with 175 thousandths for my answer. Let's take a look at example number 2. Ooh, this is touching a little bit on what we talked about yesterday with the exponent of 2. That's called, we say that is squared. So we have 2 and 5 tenths squared. Remember that doesn't mean 2 and 5 tenths times 2. It means we're using this 2 and 5 tenths as a factor twice. So go ahead and try this work. I had written this on the very first page of the slides, but make sure that when you're watching these videos, you need to have a piece of paper of some sort in front of you and a pen or a pencil to do the work. Your brain won't grow unless you try and find your errors and find out what you're capable of. So give this a try and unpause your video when you're ready to check your work. Okay, so I've set this up. I have 2 and 5/10 times 2 and 5/10. I'm going to just multiply like normal. I'm not even going to think about my decimals until the very end. So I have 5 times 5. Sorry about that. So just to give you the visual, I have 5 times 5 right here, and that's 25. 5 times 2 now right here, 5 times 2 is 10, 11, 12. The next step is really important. I'm done multiplying this 5 now. So honestly, because I'm a visual person and I like to keep things kind of organized on paper for myself, I cross that off. I'm done with it. I'm crossing it off. And I also cross that off so I don't get confused. My next step is super important. I need to put down a placeholder. This is something that gets forgotten all the time, and it absolutely affects your answer. So we have a placeholder. Now we're ready to do this work. 2 times 5 is 10. Sorry. 2 times 2 is 4, plus 1 more is 5. And we're going to add up these numbers. So we have, I'm going to scroll down a tiny bit. We have 5 plus 0 is 5. 2 plus 0 is 2. 5 plus 1 is 6. We're not done yet because we need to determine where our decimal goes in this product, in this answer. So I go back to my original problem and I'm going to count back decimal spots or decimal places. And I'm going to start here at the back on the right. Down here I have 1 decimal place. Up here I have 1 more decimal place. Altogether I have 2 decimal places that I have bumped back. I need to do that in my product. So I start back here and I go 1, 2. My decimal goes right here, and I end up with 6 and 25 hundredths. I've mentioned this before, but just in case you haven't heard me say this, anytime in math you see a decimal point, you read that as the word and. So this is 6 and 25 hundredths. Let's look at this example. A mile is about 1 6/10 kilometers. Mark Cruz ran a 3-mile cross-country race. About how many kilometers did she run? Give this a try and unpause your video when you're ready to check your work. I've been finding myself mentioning this a lot lately, but reading math and computing math or solving math problems are 2 very different things, and both are equally important. So really make sure when you're looking at word or story problems, you're reading the problem correctly and very carefully to determine what you need to do to solve. So we're told that she ran 3 miles. 1 mile is approximately 1 6/10 kilometers. So really what we're needing to do here is multiply 1 6/10 times 3 to determine about how many kilometers she ran. Okay, so I haven't lined up any decimals or anything. I'm just ready to multiply like normal. This is an example of multiplying a decimal number times a whole number. So 6 times 3 is, I should visualize here, 6 times 3 right here is 18. We have 3 times 1 is 3, plus 1 more is 4. 16 times 3 is 48, so that makes sense. Going back to my original problem so that I can determine where my decimal goes, I have no decimals here visually to see. I don't have to count anything there, but up here in this factor, I have 1 decimal place, 1 decimal space. So I start at the back of my product, my answer, and I go 1 decimal space. And I end up with 4 8/10. This is a word problem or a story problem. Let's make sure we add a label. They're asking us how many kilometers, and I can abbreviate that like this. 4 8/10 kilometers. Okay. So that